All right, functions. We are going to move on to using the rules of exponents with rational exponents. So remember, when we hear the word rational, we should be thinking fraction. Just like rational expressions that we just did in the last unit, we're all fractions. Now we're going to have fraction exponents, so rational exponents. Here are the rules that we've covered. We know some of these from 8th grade, and then some of these we've kind of been reiterating throughout this whole unit. So remember, when we multiply, we have the same base. We're going to add the exponents, and that's because if we think about it, if we have x squared times x cubed, well, I can rewrite that as x times x times x times x times x. Well, how many x's do I have? Well, I have 5 x's, so that would be x to the 5th. So that is why that rule works. This one we learned that when it's negative, we're going to move it down to the denominator if it's in the numerator, because remember, it's over 1. And then here, if I have a to the r over a to the s, since we're dividing, we're going to subtract those exponents. So when we multiply, we add. When we divide, we subtract. This one, when we take a power to a power, we multiply those. So again, that would be like x squared to the 3rd. Oops, I wrote to the 3rd. Well, that would be x squared times x squared times x squared. Or 1, 2, 3, we add those and I get 6. Or I could have just done 2 times 3, which is 6. So that's why that one works. This one we know, we've been using this, I know in Algebra 2, but also last semester. So that would be something like 4x squared is going to be, well, we have to square the coefficient, which is 16, and the x squared. We learned that, we practiced that a lot with sum and difference of cubes. This one we've been using all the time. If it's on the outside of the whole thing, we can do it to the numerator and the denominator. We talked about that. When it's negative, remember we would rewrite this as a to the negative r over b to the negative r, and then we would need to move that one and move that one. So that's how you get this, and this just reiterates this one. So make sure you hit pause and get that in your notes. All right, so now we're going to write with only positive exponents. So we talked about this yesterday. We do not ever want negative exponents. When we are evaluating and simplifying, we're going to wait to make those exponents positive till the very, very end. But we need to know that our answer can't have any negative exponents. So if we were to look at this example, 3 to the 1/2 times 3 to the 1/3. Well, we just talked about when we have the same base, which we do, those 3's, we want to add the exponents. Okay, so now we have just one base, but we're going to get 1 over 2 plus 1 over 3. Now, we learned last semester, or last unit, and we've known this probably since 3rd or 4th grade, what do we have to have? Well, we have to have common denominators. So the common denominator between a 2 and a 3 would be 6, right? And so what I would do is I would need to multiply by 3 over 3. And this one I need to multiply by 2 over 2. And I would end up with 3 over 6 plus 2 over 6. Okay? So we get 3 over 6 plus 2 over 6, and now we can add those together. Now we have common denominators, and we can add those. So 3 plus 2 is 5, and we end up with 3 to the 5/6. And then that's our final answer. We're just writing it with positive exponents. We don't need to rewrite it. We could, if it asks us to put it in the radical form, we could, but we don't need to. You're done. All right, how about this one? Well, we just learned that if we have the same base, then we're going to subtract them. So the way that I think about this is I think 2/3 minus 4/3. So that'll come in handy because if this were negative, we would have a minus negative, so we need to be careful. So when I look at this, I think 2/3 minus 4/3. So right here, 2/3 minus 4/3. Okay, we already have a common denominator, so 2 minus 4 is -2. Now we have an answer with a negative exponent. We can't keep it that way, so we need to move, this is going to be over 1, so we're going to move it to the denominator, and now we have positive exponent, 1 over 7 to the 2/3. So we just need to be careful that we don't end our answer with a negative exponent. We did want to wait, right? So this was a minus. We did want to wait, but now we are good. All right. Now I have something a little more complicated. So when we're looking at something like this, I'm going to start on the inside and then work my way out. So I don't have any other a's, so that's going to stay the same. And now I have b 2/3 minus, well, there's nothing here. So it's not going to be 0, right? So it's going to be 1. Whenever anything isn't written, right here, it's a 1. So I'm actually going to get 2/3 minus 1 right here. So now we didn't do anything with this. So I have 2/3 minus 1 over 1, right? And so the 1/1, I need to get a, so just like here, the 7 didn't disappear, it just moved, it's right here. I need a common denominator, so that's a 3. I need to multiply by 3/3. And I get 2 minus 3, which is going to be equal to negative 1/3. Alright, so now I have a to the 1/3, b to the negative 1/3. Now, we learned when we take a power to a power, and because we're multiplying these, I'm going to multiply the 6, this power times this power, and this power times this power. So it's going to look like this. So when I see it like that, it's actually, I'm multiplying the exponents. So I'm going to have 1/3 times 6/1, and thankfully top times top equals top, so 6, and bottom times bottom equals bottom over 3. And I'm going to do the same thing for the b. So I have negative 1/3 times 6/1, and top times top equals top, bottom times bottom equals bottom. So now I have a to the 6/3 times b to the negative 6/3. So now we have one step we have to do before I can mess with that negative, and that is we want to simplify our fractions. So this can be simplified. 6 divided by 3 can be simplified to 2. And negative 6 divided by 3 can be simplified to negative 2. So now, whoops, whoa, that was a little bit much. Alright, so now we have, I think when I hit this button on my pen, it goes crazy. Alright, so now we end up with a squared times b to the negative 2. Now, we can't have a negative exponent. So now we're at the end, we're fully simplified, so we want to rewrite it. Some students, when we did this in class, ended up with a squared times 1 over b squared. That's correct, you just need to finish multiplying. So this would be over 1, and that would equal this. So just make sure that you get it all together. If there's any multiplication that needs to be done, you do that. Alright, again, we are going to work with the inside first and then go out. So we're going to start with the a's, and we're going to have 3 minus negative 2. Be careful. 3 minus negative 2. And then we're going to have negative 4 minus 1/5. Okay? So when we have a 3 minus negative 2, well, that gets a plus plus, and we end up with 5. Then we have negative 4 minus 1/5. Well, again, this is over 1. And what would be the least common multiple between 1 and 5? Well, that would be 5, so we need to multiply by 5. And we're going to end up with negative 20/5 minus 1/5, which is going to be that negative 21/5. Okay, so now we have that. Now we have everything taken care of. I've got all my a's put together. I've got all my b's put together. Now I'm going to go ahead and take my powers to a power. So I'm going to, oh my goodness. You guys are getting a real preview. So now I'm going to take my powers and multiply them. So I get 5/1 times negative 1/2. And I end up with a negative 5/2. And then I have negative 21/5 times negative 1/2, which is going to be a positive 21/10. Okay, so now we have a to the negative 5 halves, b to the positive 20/10. Now we are done. All of our b's, all of our a's are together. Now we need to take care of this negative right here. And since it's in the numerator, I'm going to move it down to the denominator. So that should be your final solution. All right. Now, this one seems to throw us for a loop, and I'm not sure why, because it just says this times this and this plus times that. So if I had x times x squared plus x cubed, we know that we can't combine those because they're not exactly the same. When we have the plus and the minuses in between, we can only combine things that are exactly the same. Granted, if the coefficient's different, that would just mean we have that many of them. But if we don't have matching powers, then we can't put them together. But we can multiply them, right? We would do x times x squared and x times x cubed. So we're going to do the same thing. We're going to multiply this one first, and I'm going to use a different color. And then we're going to multiply this. So it's going to look like this. So the blue line is right here, and the purple is right here. So when we have the same base and we're multiplying, here I'll get a different color completely since we're doing that, we would add the exponents. So we have 2 over 5 plus 3 over 5, which is 2 plus 3, which is 5 over 5. And then we have 2 over 5 plus 8 over 5, which is 10 over 5. Right? That's what we did there. And there's our answer. So we have r to the 5 over 5 plus r to the 10 over 5. Now we have to be careful. We need to simplify those fractions. So when we simplify them, we are going to get r to the first power plus r to the second power. All right. I am going to do the next example on another video because I'm out of time on this one. So please make sure you get this in your notes, and if you have any questions, please ask in class. Also, you now will be able to do your homework, I think up to like 40-ish, somewhere around there. I'll check for sure and let you know in class. All right, thank you.